Hello everyone, welcome to Maths Smarties. In this video, we are discussing the questions from NBHM PhD 2021. In the video, this video contains mainly 4 questions. Question number 8, which is from linear algebra. Question number 14, which is from group theory. Question number 20, which is from linear algebra again. And question number 29, which is from complex analysis. And this is the part 6 video of NBHM PhD 2021 series. Those who are not watching the previous video, I'll share the link in the description and also here in the I tab. And these 4 questions, some of these 4 questions are based on really good and finest concepts. So I think this video is very helpful for you. So watch the video very carefully, and if you like the content, then please give a like to this video, share with your friends and subscribe the channel. So let's start with question number 8. The question 8 says that let A be an invertible 3×3 real matrix such that A and A square have some same characteristic polynomial. What are the possible traces of such a matrix A? This question is very simple, but in this question there are very interesting and fine concept. So first we note that A is invertible matrix. That means det of A is not equal to 0, and we know that det of any matrix, square matrix, equal to product of eigenvalues. That means no eigenvalue should equal to 0. That means each eigenvalue are non-zero. कोई इसमें 0 eigenvalue नहीं आएगा. Now the question, the matrix is of order 3×3 such that A and A square have same characteristic polynomial. That means the eigenvalues of A and the eigenvalues of A square are same. So let us take lambda 1, lambda 2 and lambda 3 are the 3 eigenvalues of A, and then lambda 1, lambda 2 and lambda 3 are also eigenvalues of A square. Clearly, now we know a theory. The theorem is, if lambda is an eigenvalue of A, then lambda to the power k is an eigenvalue of A square. Clear? Now therefore lambda 1 square, lambda 2 square and lambda 3 square are also eigenvalues of A square. Therefore this lambda 1 is equal to lambda 1 square. We get lambda 1 equal to lambda 1 square, lambda 2 this is equal to lambda 2 square, and lambda 3 this is equal to lambda 3 square. So this gives lambda into 1 minus lambda 1, this is equal to 0, and since no eigenvalue is equal to 0, that means lambda 1 equal to possibility is 1, and similarly lambda 2 equal to 1, and similarly lambda 3 this is equal to 1. Since the matrix is non-singular, therefore eigenvalue 0 is not possible. Therefore, and we have to calculate the trace of the matrix A. So that means we get the 3 eigenvalues, and we know that trace of any matrix this is equal to sum of eigenvalues, and this is equal to lambda 1 plus lambda 2 plus lambda 3, this is equal to 3. Now the question is not finished yet. The question says that what are the possible traces. That means we can find any other possible choice. Now you can question me what we should think about the other possibility and how. We have a result, and you can say it a theory type, so that a real matrix can have complex eigenvalues. Clear? A real matrix can have complex eigenvalues. Now, from this, lambda 1, lambda 2, lambda 3 are the eigenvalues of a square, and lambda 1 square, lambda 2 square, and lambda 3 square are also eigenvalues of a square. This gives determinant of a square, this is equal to, since determinant of a square, this is equal to product of eigenvalues, that means lambda 1, lambda 2, lambda 3. Again, from here we get determinant of a square, this is equal to lambda 1 square, lambda 2 square, and lambda 3 square. And this should equal, these two are equal, that means lambda 1 square, lambda 1, lambda 2, and lambda 3, this is equal to lambda 1 square, lambda 2 square, and lambda 3 square. So this gives lambda 1, lambda 2, lambda 3 into 1 minus lambda 1, lambda 2, lambda 3, this is equal to 0. And since product of these three, 0 is not possible since the matrix is non-singular, that means lambda 1, this is equal to 0, which gives lambda 1, lambda 2, lambda 3, this is equal to 0. That means product of eigenvalues is equal to 0. Clear? Sorry, product of eigenvalues, this is equal to 1. Now we should think about the roots of unity, nth roots of unity. Why we should think about it? Since product of roots is equal to unit, then we should think about nth roots of unity. Now here the number of roots is equal to 3, therefore we should think about 3 third roots of unity. Clear? Third roots of unity, that is. Now here to result about the roots of unity, I write it here, that is product of nth roots. Since the roots, product of roots is equal to 1, then we should think about the roots of unity. Now for product of root of unity, suppose z cube equal to 1. This is suppose an equation, and we know that the roots of this equation is of the form e power, if zn equal to 1, sorry, we take general case here, if zn equal to 1, then the roots of this equation is of the form, suppose e power I into 2 pi by n, this is the form. And in case of n equal to 3, then the roots are e power I into 2 pi by 3. And here we use to result number 1, since it is clear that in this case, the problem in this case, we get roots of unity, cube roots of unity, that is third roots of unity, that is cube roots of unity. Now the result is the sum of roots, the sum of roots of unity of cube root or nth root of unity, you can use here the general result of nth roots of unity, this is equal to 0, and number 2 is product of nth roots of unity is minus 1 power n minus 1, and here the value of n is 3, therefore the product of root is equal to minus 1 power 3 minus 1, this is equal to minus 1 power 2, which is equal to 1. Clear? So now we have to calculate the trace, and trace means we know that sum of roots of the characteristic polynomial or characteristic equation, sum of roots, which is equal to these roots of unity. That means the sum of roots of nth roots of unity, which is equal to the sum of roots of the characteristic equation, which is equal to clearly 0. We don't need to calculate any further calculations. From this result we can directly say that the possible trace is equal to, therefore our answer is, and this root is, sum of the roots is 0, therefore our answer is here 0 and 3 are the possible traces. This question is very conceptual questions. and based on very finest concept, I stuck this problem for 2 to 3 days because of this. So after that I think about it and give the solutions for these questions. Now the next question is question number 14. The question says that let G be a group homeomorphism, this is important term, group homeomorphism of real line R with its usual topology, the group operation being composition. Consider the elements fx equal to 2x, this is a given data, and gx equal to 8x of G. Suppose hx in G is such that it conjugate of f to G, that is h of f of h inverse x, this is equal to gx, and further satisfies h of 1 equal to 5. Then what is the value of h of 2? So the given data is h of f of h inverse of x, this is equal to gx, and since it is given that G group homomorphism, that means h of inverse exists, and also here we used in this the questions, given that h of 1, this is equal to 5. Since h inverse exists, so we can write h inverse 5, this is equal to 1. Now we put x equal to 5 in these questions. In these questions no concept of topology will be needed. So now we can write h of f of h inverse 5, this is equal to g of 5. Now given that gx equal to 8x, so gx is equal to 8x, that means g5, this is equal to clearly 40, so this is equal to 40 you can write. So now this implies h of f of h inverse 5 means 1, so f of 1, this is equal to 40. Now f of 1, fx equal to 2x given, again fx equal to given 2x, that means f of 1 equal to 2 clearly, therefore h of 2, this is equal to 40. This is a very easy questions, so the 40 is our clear answer, therefore h of 2 is equal to 40 is the answer. Now go to the next questions. Question number 20. This is also a very good questions. The question says that let M5C be the set of 5 by 5 complex matrices and let A be a fixed element of M5C. Consider the linear transformation TA from M5C to M5C given by x to x, that means x goes to ax, where ax is the usual matrix product of elements in M5C. If A has rank 2, then what is rank of TA? First, we know that rank of TA means, what is this? Rank of TA means dimension of image of this transformation T, image of T. Rank of T means matrix of this linear transformation. This is equal to dimension of image. So we have to calculate the dimension of image of T. Now it is given that the rank of the matrix A is 2. This information is very important, and A is fixed. Let A be fixed element of M5C. This line is also important. So, and since A has rank 2, therefore, and order of the matrix A is 5 by 5, therefore we can take the matrix A as A equal to, since we just take it A 1 1 0 0 0 0 0 A 1 1 A 2 2, and all other elements are 0 and all other elements are 0. So this is clearly a rank 2 matrix, and the elements are from complex entries. So A11 and A122 belongs to complex entries, and these are of the form Aij, this is equal to alpha plus iota beta type. Now you can questions me that why this dimension or rank of this matrix is 2. Since you can take this is of the form alpha plus beta, then should be this matrix should be is of dimension 4, since there is 2 element, there is 2 element of real. It is important, and the question says that it is completely based on complex field. So the elements are treated as complex entries, so that the rank of the matrix A, this is equal to 2. Clear? This you need to clear for these questions, very important concept. So now we calculate Ax. Suppose let us choose an arbitrary matrix Ax. This is equal to, we can take x11, x12, x13, x15, x21, x22, and x25, x31, x32, and x35, and x41, x42, x45, x51, x52, and x55. So this is a clearly 5 by 5 matrix. Now we calculate Ax. So Ax, this is equal to simply A11 0 0 0 0 0 and 0, A122 0, and all other elements are 0. So into x means x11, x21, x31, x41, x51, then x12, x22, x32, x42, x52, and all other elements 1 3 1 2 3 3 3 4 3 5 3, and x 1 4 2 4 3 4 4 4 5 4, x 1 5 2 5 3 5 4 5 5 5. This is the product, and all the entries of x are also from complex field. So this is equal to Ax1. So this is equal to A11 x1, A11 x11, and all other elements are 0. Then A11 x12, all other elements are 0. A11 x13, A11 x14, A11 x15. Complex number, product of two complex number is also again a complex number, and then 0 and multiplies by second row first column, then this gives A22 x21, A22 x22, A22 x23, A22 x24, A22 x25, and all the elements, other elements are 0. Clear? All other elements are 0. Now we get only 10 entries. These are complex entries, and we should calculate the number of elements in complex field, so that these elements are only 10 elements, not 20 elements. Since 20 elements based on real field, not based on complex field, and the question is completely based on complex field. That's why we calculate these elements in one elements in complex field. So dimension of image of TA, this is equal to, we know that this is equal to 10. That means our required rank of TA, this is equal to 10. So 10 is our answer for this problem. Now go to the next question. Question number 29. This is again a very important and interesting questions. The question says that find the real number a such that integration close interval mod of z minus iota is equal to 1 dz by z square minus z plus a equal to pi. Find the value of a. Now suppose this is the circle of mod z minus iota equal to 1, that means this is suppose the center iota and one radius, circle one radius. Now we calculate this integration using a. Now the singularities are, first we should calculate the singularities. Singularities are z square minus z plus a, this is equal to 0. Now this gives z equal to minus 1 plus minus root over of 1 minus 4a by 2. Now if this the inside the root 1 minus 4a, this is greater than 0, that means this gives a is less than 1 by 4. If a is less than 1 by 4, that is 1 by minus 4a is greater than 0, then there is no imaginary term. If this is greater than 0, so then the singularities lies on the real x-axis and non-zero points. Therefore these are outside the circle, and since our interest is the point inside the singularity inside the circle, so these are none of our business. Now if the 1 minus 4a term is less than 0, that means a is greater than 1 by 4, then this term is less than 0, and we can write this z, this is equal to 1 plus minus root under 4a minus 1. Since 1 minus 4a is less than 0, therefore we can write 4a minus 1 iota by 2. Now we have two singularities, 1 plus root over of 4a minus 1 into iota by 2 and 1 minus root under of 4a minus 1 iota by 2, these two terms. Now this singularity is also outside the circle. How can we check that? Now value of a is greater than 1 by 4, then we can take the value of a. If we take a equal to 1 by 10, which is greater than 1 by 4, if we put here, then we get 1 minus 4, a equal to 1 by 2 means 2 minus 1 iota, simply 1 minus iota by 2, which is the point 1 by 2 iota by 2 is here, minus iota by 2, 1 by 2 in this quadrant, so which is clearly outside the circle, and only this point 1 plus 4a minus 1 into iota, this is only the singularity which is lies inside the circle. Now we use here the residue theorem. Now we find the residue of fz at the point z equal to 1 plus root over of 4a minus 1 into iota by 2, which is equal to, we all know that the formula limit z tends to z0, that means this is suppose z0 point, z tends to 1 plus root under 4a minus 1 iota by 2 z minus z0 into fz, and here fz is equal to 1 by z square minus z plus a, which is equal to, we can write the product of these two terms, so into this, into z tends to z0, z minus z0, that means z minus, the singularity is this, right, second bracket, 1 plus root over of 4a minus 1 into iota by 2, z minus z0 by z minus z0, this term. So this is, you can write z minus 1 plus root over of 4a minus 1 iota by 2 into z minus 1 minus root under 4a minus 1 into iota by 2. Now this term and this term cancel. We put the value of just z0 here. This is equal to clearly 1 by, put the value of the limit 1 by 2 plus root under of 4a minus 1 iota by 2 minus of half minus minus plus root under 4a minus 1 into iota by 2. Half cancel out, and by 2 means 1, so this gives 1 by simply root under 4a minus 1 into iota. So this is the residue. Now the above integration fz dz, fz is the function given, mod of z minus iota equal to 1 equal to 2 pi I into sum of the residue, and here only one singularity, so this is equal to 1 by root under 4a minus 1 into iota. Iota cancel, so 2 pi by root under 4a minus 1. Now given the value of the integration in the question is equal to pi, we should equate this is to pi. So therefore 2 pi by root under 4a minus 1, this is equal to pi both side cancel, we square and add, then we get 4a, this is equal to 4a minus, so sorry 4 equal to 4a minus 1, this gives 4a, this is equal to 5, that means a equal to 5 by 4. So this is the answer of the problem, the value of a. This is a very interesting problem, an important problem also. The value of a is equal to 5 by 4. So if you like the content, then please give a like to this video, share it with your friends and subscribe the channel. Thank you friends. See you again in the next video.